Alright, Science, this is Mr. B. We are continuing on with our solar system chapter here to focus more on section 2, what is called the Earth-Moon system. So this section is really going to talk about how the Earth and the Moon, their relationship with one another, and it actually kind of starts just giving some characteristics of the Earth's moon that we have here. So to kind of go along there, so we have a very iconic image right here. This is Apollo 14. A lot of people, I feel like, think the American flag was painted by, and I guess by iconic could be controversial as well, was painted by Neil Armstrong. However, this picture was Alan Shepard who planted the American flag on the moon surface in 1971. So this is not from the first Apollo mission. Again, very iconic image here, again, of Alan Shepard planting the flag there. So to start this section off, they kind of just give some characteristics of what the moon, some characteristics of the moon that kind of make the moon what it is. So one big kind of key concept is that the temperature on the moon is very sporadic. There's a lot of wide range of what the temperatures can be, and the reason why that happens is because there's literally no atmosphere. The lack of the atmosphere allows the moon's surface temperature to vary tremendously. So that's kind of, again, one of their big key points there. And one reason why they don't really have an atmosphere is because gravity is too weak. There's too weak to hold on to any gas molecules. Any gas molecules will simply float away into space. And then because of this, again, this lack of atmosphere, this lack of gas molecules, and direct sunlight, the average surface temperature of the moon is about 130 degrees Celsius, so that is very, very, very hot. And at night, however, the average temperature will plummet to negative 180 degrees Celsius, which is very, very, very cold. So again, the lack of the atmosphere on the moon is kind of the reason why we have those temperature variations there. And then to go along with that, which this is kind of going to see a big kind of theme, is finding water at other places in our solar system besides Earth. Any liquid water would have long ago evaporated into space. Again, there was no atmosphere, not strong enough gravity to kind of hold there. Any water remaining on the moon must be frozen. So there is actually evidence that near the moon's north and south poles that there are in fact ice deposits. So at one point in time there could have been liquid water, possibly, maybe not, but there are in fact some frozen chunks of water. There are some ice near the moon's north and south poles. So that's probably something you might want to write down, that there is in fact ice. Again, there's no liquid water, but there is in fact ice on the moon. So again, so they kind of gave our temperature, again, very hot, very cold, because of the no atmosphere. Again, no atmosphere, kind of a big thing there. And then they get into some surface features that are present on the moon. They're what are called Maria, highlands, and craters. The Maria that are present on the moon, they're low, flat plains formed by ancient lunar lava flows. So there was, again, some volcanic activity at one point on the moon, which we'll kind of talk about that a little bit. And they cover about 15% of the moon's surface. So that's, again, important vocabulary. You already probably need to know what a Maria is. Again, they're flat plains. They're formed by lava flow that was at one point going on the moon. Then there are light-colored areas called lunar highlands surrounding the Maria. These lunar highlands, which cover most of the moon's surface, are rough mountainous regions. So there are, again, wherever there's going to kind of be a lower area carved, and there's going to be some higher mountains kind of around that. So those are called lunar highlands. Again, I know that's not a bolded word, but it's probably something that you should need to know as well. Again, and these photos kind of show some of the features of the moon. Again, the large dark areas in the top photo are the Maria. Again, so these darker areas up here, again, kind of formed from the lava flow. Again, the lighter areas are the Maria, or the lunar highlands. So right in this area would be kind of our highlands there on the lighter color. And then one thing that they have not mentioned until now is that the moon is also covered with craters that form from the impacts of smaller objects. So this bottom picture right here shows those craters, and you'll notice that there are a lot of them. So it shows that there were a lot of collisions at one point in time, or possibly still going on with objects and the moon. Again, with those craters, again, much of the moon's surface is covered with impact craters. These craters are, again, probably important to know this. Craters are just round depressions in the surface caused by the impact of high-speed meteoroids. And a meteoroid is just a chunk of rock that moved through the solar system. So those, again, are more important words, and I kind of alluded to this a second ago, that although meteoroid collisions still occur, so they are still going on the moon. Most craters formed more than actually 3.8 billion years ago. So there was a lot of collisions going on at the time that formed those craters. Again, like I said, they still do happen, but a vast majority of them have been there for a very, 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 very long time. And there's also, and this is kind of relates some kind of things that we've learned in the past here, maybe not this year in science, but in science classes before, that on Earth we had a lot of collisions, but most of our old craters disappeared as the surface was altered by erosion and by collisions between tectonic plates. So on the moon, there is no erosion and there is no plate motion to alter the craters. So that's, again, this is just kind of a bigger idea thing here. The reason why we don't see craters just dotting Earth's surface again doesn't mean that Earth has not been struck by things, because it has. It's just that we have some more powerful forces between our tectonic plates and between erosion. They're kind of eliminating those craters. Where on the moon, they don't have those. There's no erosion, no plate movement to alter those craters. And then the lunar highlands are much more heavily cratered than the Maria, which hopefully makes sense. Higher areas kind of got hit more, and then the older craters within the Maria were covered by more recent lava flows. So again, that ancient lava flow that was going on in the moon, it actually was a surface feature, or a kind of a force going on the moon that actually eliminated some of those craters that might have actually been in those lower Maria area there. So again, at one point in time, the moon did have some activity going on there, but it hasn't for a very, very long time, again, primarily because of its size there. And then I think the last little part for this section, so it kind of gave some structures of the moon. Again, some of the features there. Again, its lack of atmosphere, Maria, highlands, again, the craters. And then now they talk about, well, where did the moon actually come from? So scientists hypothesize that the moon formed after an enormous collision early in Earth's history. So this is, again, going to be some important things to write down here. About 4.6 billion years ago, the solar system was full of pieces of rocky debris, some which were the size of small planets. So there were, again, giant chunks floating around that could be the size, again, of, let's say, Pluto, maybe even a little bit bigger. While Earth was still forming, a Mars-sized object probably collided with it off-center. So when Earth was forming in its infancy, it had a collision with an object about the size of Mars. Again, it wasn't a direct hit, but it was a hit. Again, that's what it means by off-center. Again, it was not like direct smash, like direct collision. It's kind of almost clipped it a little bit. However, if you can imagine, just with the sheer size of that, this collision is going to eject a huge amount of material into space. So Earth collided. Again, it threw up a bunch of material. Earth has its own gravitational pull, so the material orbited Earth, and it eventually kind of came together and formed the moon. So I think there's a picture here. Again, Mars-sized object collision right here. Again, they did not draw this to scale. And then after the collision, some of this material started orbiting the Earth, and after a long, long time of orbiting the Earth, the materials gathered together and formed our moon. And that's what they believe. Again, no one was there to see that happen, but that's, again, based off of the evidence that we have, that's our best conclusion we can make there. So that is it for this video. Let me know if you have any questions.